Welcome to the third installment of transformation of functions. So over the last two videos, we basically set forth a framework for transforming functions via reflection, dilation, and translation. The second video then took that framework and applied it to trig functions, which isn't really a new thing. They just called it different things with the introduction of a new term, the phase, which is basically just horizontal translation. So today, a few quick questions on past paper, from past papers, both from Victoria and from some of the New South Wales syllabus. From the New South Wales syllabus, because it's only the first year of the new syllabus, there isn't a lot of questions out there. I can see there's a few asked in multiple choice, but there wasn't any in the main body. So we'll do a few multiple choice questions from the 2020 past papers. So let's hit up the slides. So it might be worthwhile for us to begin where we sort of left off from previous the previous videos of transformation. So let me just summarize. And I think it's important, and I certainly didn't introduce it in the last videos. There's a few words and terminology that some of the questions you'll see, especially in the Victorian syllabus, that I just want to make sure we're on the same page with the language. So everything sort of started when we have a function of x and it gets transformed. Let's put the equation that has all the transformations in place, so plus minus k, which is vertical dilation f. And once again, let's put everything in here. So you got x, so maybe I'll call it 1 on A. So it's actually reflective of the horizontal dilation, x minus b. I'll do minus so that we know which way to describe it, in plus c thereafter. So in here, and I'll leave some space above and below this box to basically give it some notes. So we know the two plus minuses represents the reflection. So that's reflection about the x-axis. Right? In other words, in the old way of talking, it's flipping downstairs. Similarly, this guy here, reflection about y-axis. And if the order of describing translations isn't given, I would always start with reflection, dilation, and then translation, as we did in the last 2 weeks. So next thing I want to highlight, that one there is a vertical dilation. Yep. Now, more importantly, it's a vertical dilation, but in some of the language you'll see, especially in the Victorian syllabus, sometimes I might say it's a vertical dilation from the x-axis. Right, that makes sense, because if you're at the x-axis and you're dilating, it's a dilation from the x-axis. But also another way of describing this is or parallel to y-axis. And that means for all these translations, whenever you're doing something parallel to the y-axis looks like this. If you're doing stuff to a function that's parallel to this, it means you're moving it up and down. And that makes sense, because when I vertically dilate, I'm shifting the graph. I'm basically making the graph either shorter, flatter, or taller. So the dilation effect is a movement in parallel to the y-axis. So these two sort of from x-axis or parallel to y-axis isn't really described in that much detail in the New South Wales syllabus so far, but it's certainly used in some of the questions I've seen from the Victorian syllabus. So this one here, once again, horizontal dilation. So exactly the same sort of description as the vertical, but using the new terminology also from y-axis. So if it's a horizontal, instead of saying horizontal dilation, they say dilation from y-axis, means the same thing. Or it's a dilation parallel to x-axis. So if you heard those words, it means the same thing. So last but not least, we have a horizontal translation. yeah, or a shift horizontally. Maybe I'll do it over here so I have a bit of space. And then using the same language there, it's generally, I think they can say horizontal, it's a translation from the y-axis or parallel to x-axis. And likewise there, that's a vertical translation. And if you're into some of that language there from the x-axis, because if you're moving something, shifting something vertically, it's moving away or from the x-axis, or it's parallel. The move is parallel to it, the y-axis. So that's quite nice in terms of what we've done, and obviously we did the same thing here with trig, where instead of the vertical dilation being K, I put a capital A for amplitude because that's what it's called. And also the one on lowercase a there, we basically replace that with N, which is then used to determine period. Phase would be the horizontal translation. So the B variable there would be phase. So exactly the same concept, just using different terminologies, amplitude, period, and phase, and everything else is sort of the same. So shifting up and down, I call it equilibrium. I don't know what others call it, center of motion. All right, so with that in mind, let's do a few quick questions and then we'll call it a day. So let me move on to the next slide. So this question here is from the VCE, or the Victorian equivalent of the HSC. So there's three parts to it, but very simple sort of, very simple question to begin with. So we have the graph. Let's highlight the things that are important. The graph G is obtained from the graph of the function f with rule, that's the graph, by translation by 3 + 3 units parallel. There's a new language, right? Parallel to the x-axis. So if I'm moving, x-axis is over here. If I'm moving parallel to the x-axis, that's a horizontal. So I'm shifting the graph horizontally. Left and right, that's a horizontal translation. So I'm just going to highlight that and basically just note to myself that is a horizontal translation. So the first one, pretty straightforward if you can appreciate the language. Second one, graph H, translation, once again, -1 parallel to the y. So the y-axis is going up and down, and if I'm moving parallel to this, it's a vertical translation. So once again, let me put a little note to myself: vertical translation, up and down. Yeah, and that, just to be clear, that one includes, it's basically a transformation on G. So basically A and then B cumulatively. And then graph K is obtained by H. So once again, it builds off B by dilation by a scale factor 0.5 from the x-axis. Sorry, from the y-axis. So if it's from the y-axis, that is a horizontal dilation because I'm moving away from the y-axis. So horizontal dilation. Of 0.5. All right. Sorry. While I do that, so plus, I'll highlight the amount of my transformation as well. Dilation. So that's the hardest bit, I guess, translating the English into maths, right? So because then the maths behind it is pretty easy. So for the first one, if I'm saying it starts off with y = x squared, gets transformed with a +3, +3 units horizontally. We know that horizontally is inside the function, so it'd be y = x - 3 squared, and that is, let me shift this over because I'm going to call this function by what it tells me to call, and that's g. And that's my answer. Pretty straightforward start if you can get the translations identified. So part B. So I'm starting with y equals to x minus 3 squared, and I'm translating this to h. So transforming this to h, where, what's that? It's a -1, shift down. So outside of the function, it'll be x minus 3 squared. Oops, put the equal sign there. Equals to x minus 3 squared, and then -1 to shift it downwards. So pretty straightforward, right? The maths behind it, pretty straightforward. Not too bad though. Last but not least, let's see. So it looks like I start with the h function, which is from part B, and I want to transform this into function k, where its scale factor applied to horizontally. So the x is divided by 0.5. So from a formula perspective, it basically, now I'll put in green, x divided by 0.5, right? And then everything else remains the same, which then, to simplify that, then the function for k is quite simply 2x minus 3 squared minus 1, and that is your final answer. So I guess maybe the whole point of this question is terminology. Dilation from the y-axis is horizontally, etc., etc. So I think, well, it's a nice question for us to just get down to about, because we're not sure how the New South Wales HSC writers would present transformation. It might present it like vertical and horizontal, or we might say from the y-axis, from the x, or parallel to the y, parallel to the x. So let's be prepared for it. Next question. So once again, from the VCE, using slightly different language. So let's do this question. This question works backwards, where actually it doesn't work backwards, but it basically puts in 4 transformations, and we have to derive the equation and then domain arrange it. Okay, cool. So we start with y equals to 1 on x, so a hyperbola. So I've got a dilation from the y-axis, right? So if it's a dilate, so if I'm at the y-axis and I'm dilating from the y-axis, that is a horizontal dilation. Horizontal dilation, right? So let me just write this down. So that one there, horizontal dilation, that's important. Next one, reflection, okay, y-axis though. So, I mean, self-explanatory, I'm not gonna put notes to that. So that one there, from the y-axis, so wherever x is, I put a negative in front of it, but for a hyperbola, it doesn't really change anything. Translation, right? 3 units parallel to the x-axis. So if I'm the x-axis, if I'm moving things parallel to the x-axis, that's a horizontal translation. Similarly, if I have a translation +1 parallel to the y, so y-axis is here, and I'm moving things parallel to it, so that's a vertical translation. That should give me enough to write the equation of the graph and then domain arrange thereafter. All right. So I'm gonna do, let's do these one at a time, right? So I start off with my original. It then gets, now, dilation factor horizontally. So where the x is, it's x on a, right? Yeah, you apply the factor inside a, so it goes y equals 2. So I'll do it sort of one step at a time. So if the factor is half, I basically say to myself, it's x divided by a, which is a half. So it's like a fraction in a fraction in a fraction. So I believe then you get y equals 2. So the 2 sort of comes 1 on 2x. Yep, step 1. Step 2, reflection. So basically exactly the same deal. The only difference is that there's a negative in front now. So if you can put it negative there, or just bring it outside to where the fraction is, exactly the same algebraic equivalence. So that's step 2 done. Step 3, I want to move it to the left, or left and right, in this case to the right, by 3. So where the function is, inside the function, where x is, I'm going to put x minus 3. So from a hyperbola point of view, maybe I'll put that in green just to show the new transformation. For a hyperbola, that is a shift in the asymptote to the right by 3. And last but not least, I want this whole hyperbola up by 1. So y equals to, I'll copy this guy down. It is up, isn't it? Plus 1, perfect. So then plus 1 as my final answer. So that is my final answer. I'll put a blue highlight on that. So once again, the mathematics behind that is pretty straightforward. It's more the English. It's more the, what are these translations parallel from, how they different? Just be very clear. So if it's a move parallel to an axis. If the axis was the y-axis, the move, the translation will be vertical. Yep, the dilation will be vertical. But if it's from, so for example, a dilation from the y-axis, then it's a horizontal. Because if I'm the y-axis and the dilation is happening from here, then it's a horizontal one, right? It's not moving in parallel, it's moving from it, or perpendicular, maybe sometimes you'll hear. Then it's horizontal dilation in this case. So the language here is actually quite important. And the domain range, I'll just quickly do it downstairs. Did I have to sketch this? No, no. So you can see just by looking at the asymptotes, my domain is always, now I'll write it in both the old way or real. By old, I mean not set notation, and then I'll do a set notation thereafter. X doesn't equal to 3, or X is an element of, so from negative infinity all the way to 3, excluding, intersecting with 3 to positive infinity. So both of those are correct, depending on how your school wants it for the real. So for the range, exactly the same deal, or real, or y rather. Y doesn't equal to 1, or y is an element of infinity to 1, intersecting 1, positive infinity. So both of those are acceptable, and that is my domain range. So you put a box right now, and that is my final answer. Give it a blue highlight. So that's the second VCE question that we've done. Hope that was okay. And once again, it's the language. So interestingly, and you'll see it in the next two, for the two New South Wales past paper questions, this language isn't used. They jump back onto the, what we're sort of familiar with the textbooks, and that's vertical and horizontally translating, dilating transformations. So let's do two quick multiple choice questions, and I think we're done for this topic. Oops, I lied. Let's do one more from Victoria's Kilbaha Institute. And then we'll do the two multiple choice. So this question here, once again, we've done something similar to this before, I think, or if I haven't, maybe I'm thinking about my class, but it's quite the straightforward. This used to be in the old syllabus as well, where you get given a parabola and they want you to re-express that in terms of a factorized vertex form. Vertex, because if you find A and B in this case, it sort of gives you information about the vertex. And once you do that, describe the transformations that get you from x squared to whatever that is. So in the old syllabus, they used to do this. They just don't get you to describe the transformation. So part A. So if they gave you that the function gx equals to 2x squared minus 12x plus 31, then it is a case of trying to complete the square here. So I'm going to highlight that. Actually, before I do that, let's factorize the 2 out and then complete the square with the remaining quadratic inside that. That's not a nice divisible by 2 number. So we'll just put it as a fraction. Bring it inside the fraction, inside the bracket, add 9 to complete the square and simultaneously minus 9. So once you do that, you sort of get x minus 3 all squared. And this guy here now, what is that? That's minus 18, 31 minus, is it 15? No, 18, 13. Let me just check that. I don't want to mess it up. 13 on 2, brilliant. And then sort of expand that bracket using rainbows. So sort of this guy times this and this guy times that. Then you get the final answer to be 2x minus 3 all squared plus 2's cancel out, that's 13. And that is your GX repackaged into the form where A equals to minus 3 and B equals to 13. That is your answer. So nothing about that is new syllabus. It's part B that is new syllabus for New South Wales at least. Yep, that's part A, pretty straightforward. Now, part B. I want to know the transformations that get me from fx, which is x squared, right, all the way to gx, which is 2x minus 3 squared plus 13. So let's unpick this, right? So I got, like I did last week and the week before, I got vertical dilation there. I've got horizontal translation there, and I've got vertical translation there. So in this case, the order isn't given to you. You got to set your own order. Now, there's so many ways to do this. To be safe, what always works is that if you go reflection, dilation, translation, and then if you want to, as a rule of thumb, do vertical before horizontal, you don't go wrong. So my transformations include, so I'll go vertical first and dilation comes before. So vertical dilation by factor of 2. Yeah, so then vertical translation, and that is plus 13, so upwards by 13. Last but not least, horizontal translation. Now that's minus 3, which is to the right, by 3. So quite easy, and just language, careful with that. Obviously, if you wanted to go from X or Y axis or parallel and stuff, you can. But let's play it safe. That's what we did last week, and that's the answer. Hopefully that's not too bad, right? Not bad for a Kilbaha past paper question. Now I believe we're gonna hit up some New South Wales multiple choice questions. So I like these two because this one here from Sydney Girls and the next one from North Sydney Girls, not too easy, right? Multiple choice. Let's have a look. Let's have a look. So in this year's trials, Sydney Girls asked the graph. Let's see, let's unpick this, right? So I'll highlight this guy here. That's the original. Dilated vertically and horizontally. So 2 dilations and then reflected and then reflected. So if they give you order, then you must go by that order. If they don't give you order, then you go reflection first. In this case, reflection's last. So I don't know whether that will, I think that does change things, especially if it's reflected on the Y, because a negative has to go inside where the X is. So let's start this, right? So we're gonna basically start off with an original function that looks like this. And I'm gonna transform this and get the equation. So first transformation, let's do this. So we have a vertical translation, vertical dilation of a half. So what that means is, quite simply, I'm going to pop a half in front and be done with that. So that's just a half there, and everything else is the same. So that was an easy transformation, piece of cake. The next one is a bit trickier. Horizontal dilation by 3. What that means is wherever I see the X, I put it over 3. So I say it's a bit trickier, but I mean, it's if you wanted to simplify it, but I don't think they're simplifying it. So I'll leave that half there, that's in now. So I'm just gonna set that two brackets, minus 2 stays the same with the squared. The 3 plus stays the same. The only thing that's different is where they were previously x's. I'm dilating that by 3. Yep, so it sort of looks like that. So for horizontal, it's always on A, right? So in this case, A is 3, so x on A, x on 3, x on 3. So pretty straightforward. So I've done those two dilations. The last one reflected about the y-axis. If it's about the y-axis, it's like flipping sort of horizontally. The negative has to be where x is, right? So wherever you see the x is, that guy and that guy there, make that into negative x. So from an algebra point of view, let's see where that takes us. I suspect in this question, once I put in that negative, the question would ask me to then simplify it. So if I put the 3, just to show you that they're not the parts that I'm changing, this part here is the part that I'm changing. So theoretically, that is my answer. I just now need to clean up the algebra because you can see there's none here that still have the negative x there. So, I mean, we know from our algebra, if I have a negative and a negative there, theoretically, I can factorize the two negatives out. They both become positive. And when you square it, the negative goes away. What am I trying to say? That technically speaking, those negatives can just disappear to being both positive. Because if they're both negative, it's like when you square negative 3, the negative sort of goes away, right? Same here. If you factorize the negative out, they become plus, square that. And then on this side, it's 3 plus minus, so that's minus x on 3. And if you look at the cases that look like that, so from an elimination, that negative, so I want half there, so that guy's gone, that guy's gone, that guy, so I want x on 3, so that guy's gone as well, so the only answer left is D. How's that? So the order in this one is given to you, but then it becomes just an algebra question. Not too bad, hopefully. But once again, it's a new language of transformation that might be a bit difficult for people. So that's the Sydney Girls question. Let's do one more question and wrap it up with that from North Sydney Girls. I like this question because the order here messes people up. So let's have a look at the question. So from North Sydney Girls, it says we have a graph fx equals a sine x, so a sine graph. It's transformed into gx, like this. Which of the following correctly describes the order of transformation? Now, so let's see. Interestingly, all of these are dilations, right? Dilation, 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 followed by translation horizontally, and then dilation, dilation, right? These two, the order is different. And then dilation, dilation, translation, translation. Now, we know as a rule of thumb, if I did this without any order, I'll go vertical, then horizontal, dilation, and then translation, right? So basically, I would do it in this order here. Sorry, I was going to highlight. Oops. Dilation, dilation, dilation. I would basically do it with these two here first. Sorry, in that order. So let's see if these two here are used. Be careful in this question. I'll explain why. I don't want to give it away too much, but let's work as if we didn't know what the answer was. And so from this diagram, we're going to basically say to ourselves, what have they done to transform sine graph into this one? So just to identify, if you can see the amplitude is halved. Amplitude is halved. And also, now a normal sine graph, just to be clear, a normal sine graph sort of looks like this, right? Sort of. Where highest it goes towards 1, lowest is -1, starts at 0 and goes to 2 pi. Yeah, starts at 0. So this one doesn't start at 0. So it looks like it starts there, right? In other words, it looks like it's got a horizontal translation to the left by pi on 4. Now I'll write all those down in a sec, but I've got, now so if the amplitude comes down or is shifted, that's a vertical dilation. If it shifts over to the left by pi on 4, that's a horizontal translation. Last piece of the puzzle, you can also see that a wavelength, it used to be, a full wavelength used to be 2 pi. A full wavelength now goes from that to that, and that gap there looks to be just pi. So what that means is, what changes the period, what impacts the period from a transformation point of view is a horizontal dilation. So it's been compressed. So it's basically dilated horizontally by a factor of 1/2, right? Because if I doubled it, the dilation would be 2. If I halved it, the dilation factor is 1/2. So the reason why I'm highlighting that is because they're and there's no reflection. So that was upside down as well. Then there's a reflection. There is no reflection. So what I'm going to do, I'm going to highlight the 3, or just put some words to describe the 3. So that one there is a vertical dilation by 0.5 or factor of 0.5. That one there is a horizontal translation by minus that, and I'll put minus, I'll say to the left in the actual answer, but by pi on 4, and that one there is a horizontal dilation. Yeah, it's a compression, right? By factor 0.5. It's 0.5 because I'm compressing it, right? If it was widened, then it'll be 2 or something greater than 1. Yeah. So with those 3, what I'm going to do is I'm going to put down the order and the formula that I see it. If I was to do it without the answers, right? I would say this graph would be y equals 2. Yeah. If it was sine x to begin with, I would put down the 1/2 to vertically dilate, and then sine. I will put down the 0.5. Well, sorry, I'll put down another. So it's 1 divided by 0.5, 1 divided by 0.5 to horizontally dilate, and then to shift it. So I'll go bracket x minus, or plus in this case, pi on 4 to horizontally translate. So my 3, that guy is vertically dilating, that guy is horizontally dilating, and that guy is horizontally translating. So in terms of a simplified formula, 1/2 sine 1/2 is like 2x plus pi on 4. Now, it's important, in this case, it doesn't say to find the equation, but I'll tell you why I'm doing it. Yeah, because with this, let's see if there's any answer that ticks the box. So what I want, and just to be clear, if I wanted order, I'd say vertical dilation by 1/2 or factor of 1/2, and then I'll go horizontal dilation by factor of 2, no, 1/2, and then horizontal translation to the left by pi on 4. Now let's see if anything ticks the box. So let's once again use elimination to do this, right? Now I want vertical dilation, so that guy's gone, right? That guy's gone, because that's 2, right? Gone. Vertical, yes, 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 tick, tick, tick. So they're all good. All 3 of them are good. Now, horizontal dilation by 1/2. So this one says horizontal pi on 2. That's false. So that's gone. This is between C and D. Yeah, between C and D. Or is it actually horizontal translation? So this is saying horizontal so maybe I'll look at the dilation. Horizontal dilation by, that's a tick actually. Yeah, because remember this case, the dilation is sort of switched. So maybe in terms of my highlighting, it's going to switch the highlighting colors. I'll switch it around just so dilation, so I don't get confused. Dilation, and this is translation, translation. Okay. That's actually a tick. This one's still a false. That one, that's a false, and that's a tick. So basically, that guy's ruled out. That guy's ruled out. Yep, I have 2 choices left. Now, horizontal translation to the left by pi on 4. This is where it gets interesting. None of these are right. So what does that mean? No right answer now. This is where the order is absolutely crucial. So I know if I went with my order of dilation, it has to be pi on 4. So the fact that this one here has my order and it doesn't have pi on 4, that is a genuine cross. So if I had to choose an answer right now, it looks like it's this one. And the answer is this one, but let me explain why. If you think about it, if I change the order, if I wanted to translate before I dilate, if I swap the order here, this is what it'll look like, right? This is why it makes sense. If I wanted to translate before I dilate, you basically are effectively expanding this bracket inside the sign and having 2x plus 2 times pi on 4, that's pi on 2. So if I was to translate first and dilate, I basically would go, now it's still vertically dilating by a half. But what's important here is if I translate first, right? Because the bracket's gone and I'm using this pi on 2 now, I will be translating to the left by pi on 2, right? Pi on 2 is the translation. And then I horizontally dilate by half. So if the order was different, I will, in effect, translate by pi on 2, which is the answer. So I guess what I'm trying to say in this case, they specify the order, and the order is slightly different to what we're used to, and that changes the answer. So be aware, please, and the answer, sorry, just to be extra clear, the answer is therefore B. So be aware that sometimes if the order is different, the equation that you're familiar with changes. Just thought I'd show you that question because I thought it was a nice way of messing up the order and basically for us to be able to react to it. So that's transformation of functions as a topic. There were 3 lessons I did on it. Hopefully that gives you a bit more clarity of what these terminology, the new terminology in the new syllabus means and what it refers to. So if you like that, like those 3 videos, please give me a like, give me a subscribe, tell your friends, and I'll see you next time for the next lesson. Thank you.